Hello everyone, welcome to IIT and Gate classes. This is lecture 16 on TOC, and in this lecture we are going to complete our chapter 3, that is PDA and CFLs. Okay, so in the previous lecture we were discussing about one language, that was hash palindrome, in which we have W followed by hash followed by W transpose. Okay, that means reverse of W will be placed after hash, and it was known as hash palindrome, and we have constructed PDA for it, and it was the given PDA. Okay, so I hope you remember all these things. If you are not able to remember, please watch my previous lecture. And the main advantage with W hash W transpose was that we have hash in between W and W transpose, so PDA will get the idea that when cutting will be start. Okay, so entire W will be pushed onto the stack, and whenever hash will come, then we will ignore the hash, and after that PDA will start cutting. Okay, so I hope you remember all these things. Okay, so in this lecture we are going to start W transpose, and in the previous lecture itself I have told you that this is homework for you. Try to construct DPDA for it, and I have already told you in the previous class itself that we won't be able to construct DPDA for it. We can construct only NDPDA for it. Reason being, we do not know when W will end and W transpose will start. Okay, the main problem is when W will end and W transpose will start, we do not know. So hence we have to guess the, you can say, middle part. Okay, or we have to guess where W end and W transpose start, and this guessing is done with the help of NDPDA, or non-deterministic push down automata. So let me construct NDPDA for it, and let me show you delta moves. The main advantage with delta moves will be that you will be able to easily recognize that it is NDPDA. Okay, so let me show you. Okay, so the very first move will be delta Q naught. Okay, Q naught A Z naught. It will be Q naught A Z naught. Okay, so if W is starting with A, so we will push that A into the stack. Okay, or if W is starting with, see here, if W is starting with A, we will apply this move. If W is starting with B, then we have to apply move, that is Q naught B Z naught, that is equal to Q naught B Z naught. Okay, now, now, now see, A after A we can have B, after B we can have A, after A we can have A, after B we can have B also. Okay, so we have 4 possibility. So let me note that down. After, see, after A B means what? We are reading A from the stack, and sorry, we are reading A from the tape and B from the stack. So that means what? After B we are getting A. Okay, try to imagine this thing. See, this A is read from the tape and this B is read from the stack. So this B is read from the stack. That means what? B has been pushed. Okay, and B has been pushed just previously. So that means what? After this B, we are getting A. Okay, I hope I have made the point clear. Or if you are not able to follow, then just leave this point. I am just giving you idea. That's it. Okay, so Q naught and A and B both will be pushed onto the stack. Okay, and if we have, say, BA, then again no problem, Q naught BA. Okay, so there is no problem till now, but see here, now problem arises, Q naught AA. What does this mean? After, see, we have read A from the stack and we have read A from the tape. So what does this mean? This means what? This means what? See, because we have read A from the stack, that means what? Previous symbol was A, like this. See here, previous symbol was A. Okay, and we have read A from the tape. That means what? The current symbol which we are going to read is also A. Now, previous was A and current is also A. So what does this mean? There may be chances that we have to do cutting, or there may be chances that we have to push, like here. See, the previous was A and the current is also A. See here carefully, previous was A, current is also A. That means what? We have to push here, but here previous was A and current is also A. That means what? We have to do cutting. So we have a choice here. So we will apply 2 moves here. That will be Q naught AA. That means we can push these 2 A's, or you will move to state number Q1 and push nothing onto the stack. That means what? You have to start cutting. Similarly for B also. So delta Q naught BB. What does this mean? Q naught BB. That means you can push these 2 B's, or 2 B's means the B which you have read from the tape and the B which you have read from the stack. You have to push both the B's onto the stack, or you will start cutting. That means Q1 null. Now, so this is the non-determinism. Now, see, we have two moves. Okay, again we have two moves. So we should have unique move, but we have a two moves, or you can say we have a choice here. That means on Q naught, if previous symbol was A and the current symbol is also A, that means what, you have read A from the stack and A from the tape. Then there is a choice. That means you have to push the A onto the stack, or you are going to push nothing. That means you will start cutting. So hence we have two possibilities. I hope I have made the point clear to all of you. Now see here. Now the work of Q naught is over. Now we will add Q1, and on Q1 we will have only two possibilities. That means what? Read B from the tape and B from the stack, or read A from the tape and A from the stack itself. So you will push nothing onto the stack. Q1 null, and here also Q1 null. Okay, so we are not changing the state because our mind makeup is not changed. Okay, our mind makeup is changed. That see, Q naught was the main use of Q naught was push the W, and the Q1 is cut W transpose and W. Okay, so now we are doing cutting. That's it. So after everything is over, so what will you say at Q1? Whenever Z0 is read from the stack, you will say PDA will get excited. It will read nothing from the tape, and it will jump to QF state, and that is your final state. And it's your choice, because we are making a final state. So it's your choice, put Z0 or push nothing onto the stack. It's your choice. So let me push nothing onto the stack. Okay, so it's our own choice. That's it. So this is your PDA for WW transpose. Okay, so we have constructed NDPDA. We are not able to construct DPDA. Why we are not able to construct DPDA? Because without choice we cannot make it now, because we do not know when W is ending and W transpose is going to start. That's it. So I hope I have made the point clear to all of you. Okay, so let me put everything on one slide and you can note it down carefully. Okay, and if you want me to construct your state transition diagram, then obviously from this delta moves I can construct it. I have constructed delta move so that you get proper clarity about why this is NDPDA. Okay, so we do not have unique move everywhere. We have a choice here. Okay, so that's why this is NDPDA. Okay, so or if you want me to make a state transition diagram, then I can easily make it from here by seeing from these delta moves itself. So let me construct it on Q naught. Okay, on Q naught, A Z naught, A Z naught, B Z naught, B Z naught. Okay, and we want 4 new moves now. So let me put it here. Yeah, now we have a proper space. Okay, so after that, A A A A, B B B B, A B A B, B A B A. Okay, so everything is pushed. And another possibility can be A null, or you can say B null. We are going to Q1, and on Q1 we will say A null, B null, and as soon as on Q1 Z0 is read from the stack, we will read nothing from the tape, and we will jump to it's our own choice. So in delta moves, I have pushed Z0, I have pushed nothing onto the stack. So here also I will push nothing onto the stack, and we will move to QF state. Now we have labeled it QF. So let me label here also QF. That's it. So this is our final answer. So I hope I have made the point clear to all of you. You are able to construct yourself also. Okay, so that's it. So let me put everything on one slide so that you can note it down carefully. Okay, and we will jump to your next uh, next slide. Okay, please note it down carefully. Okay, so conclusion, final conclusion, let me say it here only, then I will move to slide. Final conclusion is that NDPDA is more powerful than DPDA. That means what, there are some languages which are accepted by NDPDA but not by DPDA. Okay, this is, I think, clear. So see here carefully. Conclusion is what? Let me use different color. NDPDA is more powerful than DPDA. That means there is a CFLs for which can be accepted by NDPDA but can't be accepted by DPDA. Okay. So that's it. So NDPDA is more powerful. Okay, so you have to remember this fact. This is very, very important point. Okay, now let's move to the next slide. See here, L is A power n, B power n, C power n, N is greater than equal to 0. Can we construct PDA for it? Try to construct for this. Okay, A power n, B power n, C power n. So how will you construct it? So let me give you some idea, or let me try. you will push all the A's. Then when B come, then you will do pop. So push pop is and because these two are equal, so now stack will become empty. When C will come, then stack should be empty. So you have, what can you do with C? Okay, so you can push or you can pop up, or you can see, you can push or you can ignore. Ignore means what? You are not pushing them onto the stack. That means you are just ignoring them. Okay, and pushing means what? You are pushing the C's onto the stack. So whatever way you do, we cannot guarantee that A, B, and C are equal. Obviously, we can guarantee A and B are equal because here we are pushing and here we are popping. So after popping, whenever C comes, then we will say that stack should be empty. So stack is empty, that means what? A and B are equal. But how will you count the number of C's? This is the very big question. So you are not able to answer it. Hence, PDA cannot be constructed, and hence we will say that it is a CSL or context sensitive language. So the basic idea is whenever we have three comparisons means what? A comparison between A, B, and C. Okay, all three are compared. That means it will be CSL. Or you can say like this: number of A's and number of B's, one comparison; number of B's and number of C's, two comparisons. So we have two comparisons, or you can say we have three comparisons in terms of A, B, and C. A, B, and C all should be equal, na? So in that scenario, whenever we have three comparisons, in that scenario, we will say that it is CSL. This is a shortcut. You have to remember it. This is very basic shortcut. Okay. Or another way of saying can be, we have two comparisons. Okay. So two comparison in the sense, see, A, number of A's and B should be equal, and number of B's and C should be equal. So indirectly, we are doing two comparisons. So whatever way you like, you can do it. The main thing is it is not CFL. Okay. It will become CSL. Please note it down. I'm jumping to next slide now. Yeah, I hope you have noted down. So I'm jumping to next slide. See, now we are going to solve some questions. Okay, try to answer them carefully. A power n, B power n, C power m, n is greater than m. So again, we are trying to compare A, B, and C. That means three comparisons. So obviously, it will be CSL. Okay, it won't be a CFL. This is not CFL. Why this is not CFL? See, A and B are equal. Same problem. A will be pushed. B will from B we will do popping. So we can guarantee obviously A and B are equal. But what about C? We should say that C should be less than A's and B's. Na? C should be less than number of A's and number of B's. So how will you guarantee that? Okay, because now stack is empty. Okay, so you cannot guarantee that. So it is CSL but not CFL. Similarly, here also we have three comparisons, that is between A, B, and C. Okay, so I think I have done here a small mistake. Let me do it N. Okay, so M should be less than N, or whatever may be the scenario. Okay, so here what can you say? I can say that push A, and from C we will do popping. That means A and C can be equal. Now how will you say, what will you say about B? Okay, so B will be left, you can say, unchecked, and directly indirectly we are comparing A, B, and C. This is a small shortcut you have to remember. Okay, this is very basic and very easy shortcut, that whenever we have comparison between A, B, and C, then that will become CSL. Okay, so it will be CSL but not CFL. Okay, it will be CSL but it won't be CFL. Next question. A power n, B power n, C power 2 n. Again, comparison between A, B, and C. So it will be CFL. But it won't be CFL. It will be a CSL. It won't be CFL. Please note it down carefully. I'm jumping to next slide. Okay. Yeah. So next slide is DCFLs. So what now I'm going to introduce a new term, that is DCFLs, and this will be the last topic of your third chapter, that is PDA and CFLs. Okay. So DCFL is what? Class of languages. Please see here carefully, otherwise it will trouble you a lot. Please see here carefully. So the thing is class of languages accepted by DPDA final state. Okay, we are not concerned with null store. We are concerned with final state. And I have already told you that DPDA with final state is more powerful than DPDA with null store. But in case of NDPDA, NDPDA with null store and NDPDA with final state, NDPDA with null store and NDPDA with final state, both have equal power. But DPDA with null store and DPDA with final state both have different power. And DPDA with final state is more powerful than DPDA with empty stores. Okay, so I hope I have made the point clear. And so class of languages accepted by DPDA final state is called as DCFL. Okay, please note it down carefully. So DPDA final state If a language is accepted by DPDA final state, then it is known as DCFL. Okay. So now the question arises, how will you check that L is DCFL or not? How will you check this? So see here, this is very, very simple. When will you say that we are able to construct DPDA? Whenever we are able to construct DPDA with final state, then that language will be DCFL. So when can you guarantee that we will get DPDA? DPDA means what? Deterministic. Deterministic means what? You should have clear-cut idea about push pop. Okay. So there is no confusion about push and pop, and also there should be no confusion about number of push and number of pops. Okay. So when to push, when to pop, this should be clear. And how many symbols are pushed and pop, this should also be clear. So see here carefully. Any confusion in push and pop, that means what? When to push, when to pop, this is not clear. Or how many symbols push pop, this is not clear, then it won't be DCFL. Okay, so if any confusion in push pop or how many symbols push pop, then L is not DCFL. Please note it down carefully. This is very, very important point, and it will help you in identification of DCFL. Okay, please note it down carefully. Let me put everything on one slide so that you can note it down carefully. Please note it down. Okay, so I'm jumping to next slide now. Okay. Yes. So now see here, we have different questions, and we want to check whether this is DCFL or not. Okay, so we are going to check these are DCFLs or not. See here carefully. A power n, B power n is greater than equal to 0. Obviously, this will be DCFL. Why it will be DCFL? Because there is no confusion between push and pop. Okay, so here push, this will be push and this will be pop. So all the A's will be pushed, and whenever B come, then we will do popping. That's it. So it will be DCFL. Okay, and this is obvious point, but let me tell you. See, NDPD is more powerful than DPDA, na? Okay, and class of languages accepted by NDPDA, that is known as CFL. Please note it down carefully. This is also very, very important point. So when can you say we have a the given language is CFL? If you are able to construct context-free grammar generating it. I think I have told you in lecture number 14, the same point I have told you in lecture 14, but still I am revising so that there should be no confusion in your mind. So CFL means what? There is a CFG, or you are able to construct NDPDA for it. Okay, please note it down carefully. We should be able to construct NDPDA. DPDA is not compulsion, NDPDA is compulsion. So you should be able to design NDPDA, or you should be able to construct context-free grammar, then language is CFL. And when can you say language DCFL? We are able to construct DPDA. And DPDA is less powerful than NDPDA. So obviously, what can you say? That DCFLs, okay, DCFL will be proper subset of CFLs. Okay, so every DCFL is CFL, but every CFL is not DCFL. Why every DCFL is CFL? This is very, very simple scenario. Every DCFL is CFL because for DCFL we are DPDA, and every DPDA is also NDPDA. Okay, so I have told you many times these concepts. I have told you many times in previous lecture also, that is lecture 15, and in lecture 14 also. Okay, so please note it down carefully that every DCFL is CFL, but vice versa not true. Okay, yeah. So let's go to the next question. A power n, B power m, n is greater than m. Again, very, very simple. You do push, and here you do pop. Okay. So I hope I have already designed DPDA for all these questions. So you should be able to say directly that all these are DCFL, but I am revising the concepts. So A push, B pop, and whenever you can say string is over, then we should say that in the stack we should have A. That is the main difference between A power n, B power n, and A power n, B power m. In A power n, B power n, see here, whenever string is over, we should say stack is also empty. But here we should say whenever string is over, stack should not be empty. Stack should contain A's. That's it. At least one A should be present in the stack. Then we will say that this is the language. Okay. And there is no confusion in push pop. Nah, that's why. Leave everything. Just say there is no confusion in push pop. That means what? The language will be DCFL. Okay. Now see here, A power n, B power m, n is equal to 2m. Again here it will be DCFL. Why? Because you will push A and you will do and after all A's are completed, you will do popping with the help of B, and n is equal to 2m means what? Number of A's are double that of B's. Okay, so number of A's are double. So if you are getting confused, then this language is equivalent to saying as A power 2 and B power n. And please watch my previous lecture. I have already told you about this language, and we have constructed DPDA for it now. So hence it is DCFL. And see here carefully, there is no confusion. Okay, So first A will be pushed, second A will be ignored, third A will be pushed, fourth A will be ignored, and so on. Okay. So in that sense, whenever B will come, then we can do cutting. Okay, so I hope I have made the point clear. Logic is clear. That means what? There is no confusion in push and pop, so it is DCFL. Similarly, here also there is no confusion in push and pop, so language will be DCFL. And if you want to, if you want that I should say a few lines about it, then I can say it for you. See, the language will be, this will be equivalent to saying as A power n, B power 2n. Okay, so here what? A all A's will be pushed, and while pushing, we will push two A's. Whenever single A is read, we will push two A's onto the stack. Okay, and whenever B comes, then we will do cutting. That's it. So there is no problem at all. So this will be DCFL. Okay, so I hope I have made the point clear. Okay, so let's put everything on one slide. Please note it down carefully, and I'm jumping to next slide now. Please note it down carefully. Okay, so let's jump to next slide. Yeah, so again, few questions. A power n, B power m is equal to n or m is equal to 2n. This is very, very important question. Okay, so the same language can be written like this also. M is equal to n means what? A and B's are equal, or m is equal to 2n means what? B's are twice that of A's. So this language can be written as A power n, B power n union A power n, B power 2n. Okay, I hope I have made the point clear. So this entire language can be written like this also: A power n, B power n, A power n, B power 2n. Now see here carefully. If we have a string like triple A, triple B, we are human, we have eyes, and we can say this is part of this language. So we can say that each and every A will be pushed, and whenever B comes, then we will do pop. Similarly, if we have a string like this, triple A and 6 B's, so we are human, we have eyes, so we will say for first A you will make 2 A's, for second also, third also. That means what? Each and every A will become 2 A's, and we will push them into the stack. Okay, so read 1 A from the tape and push 2 A's onto the stack. This is the main logic here. And here read 1 A from the tape and push that A onto the stack. This is the logic here. So we are human, we are able to see, and we are able to guess that this string is a part of this language, and this string is part of this language, and so on. What about my PDA? Now PDA will, as soon as PDA will read this A, it have to take decision. It has to take decision about we have to push single A onto stack, or we have to push 2 A's onto the stack. The PDA is not able to decide this thing itself. Okay, so hence we need non-determinism here. So it will be non-deterministic push down automata. So hence this language is not DCFL. This is not DCFL. So here we do not have confusion about push and pop. We have confusion about number of pushes and pops. Number of push and pops. There is a confusion in number of push and pop. So when we read this A, we have to push 1 A. Whenever we read this A, we have to push 2 A's. Okay, so how many symbols are pushed or pop? There is confusion here. So hence this language is not DCFL. I hope I have made the point clear to all of you. Okay, or if you are not able to follow, please rewind the video and watch it again. Next question: A power n, B power n, C power m, n comma m greater than equal to 0. So see, you will say that sir, we have three comparisons and so on. No. We have comparison between A and B. C are free. Okay, so what can you say? C, A will be pushed, B will be popped, and C, whenever C will come, there is your choice that you push the C onto the stack or you ignore them. So it hardly matters. So main thing is there is no confusion in push, pop, and so on. So it will be DCFL. Next question: A power n, B power m, C power n. So again, A will be pushed. Okay, B will be ignored, and C will be pushed. Sorry, C will be popped. Okay, so whenever C will come, then we will do cutting. So that means what? This is DCFL. There is no confusion at all. Okay, so let me give you one string so that you get the idea. Triple A, double B, triple C. This is a string in this language now. Now see here, A will be pushed, B will be ignored, and whenever C will come, then we will do cutting. Okay, let me give you some idea so that you will get this clarity. Z0 is initially into the stack, so we will push all the 3 A's. We will push, we will ignore these B's. Whenever C will come, we will do cutting. That's it. Okay, so I hope I have made the point clear. So this is first class DCFL. Okay, so let me put everything on one slide. Please note it down. I'm jumping to next slide now. Please note it down carefully. Okay, yeah. Next. A power n, B power m, C power n plus m. Is this DCFL? So see here, A will see. C is what? C is sum of A's and B's. Na? Sum of A's and B's. So how will you do sum of A's and B's? So obviously A will be pushed. B will also be pushed. So you total A's and B's are pushed. Now whenever C will come, we will start popping. Okay. So C will cut B's also and A's also. So let me give you some idea so that you get the crystal clarity. 2 A's, 3 B's, and 5 C's. A power n, B power n, C power n plus m. So 2 plus 3, 5. So we have 5C here. Now see here carefully. So you have Z0. Now we will push 2 A's. We will push 3 B's. Now whenever C will come, we will do cutting. Okay. So B will be cut also and A will also be cut down. That's it. So this is DCFL. Similarly, here also this will be DCFL. So how will you show that this is DCFL? A will be definitely pushed. Now whenever B will come, we will do popping. Whenever we will see Z0 into the stack, that means we have done popping. Then we will again try to push the B's, remaining B's. And whenever C will come, then we will do pop. Okay, so let me give you some idea so that you got the clarity. So see here, we have 2 A's, we have say 5 B's, and we have say 3C. So what will you do? Okay, so initially we have Z0. We will push these 2 A into the stack and we will do popping. B with B, we will do popping. That means we will do cutting. And whenever B is read from the tape and Z0 from the stack, we will start pushing the B's. Of course, you have to change the state. I'm not going into the detail. I'm not going into implementations. I'm just showing you the logic. So we have pushed. Now C will come. Then we will do cutting. That's it. Okay. So very, very simple scenario. So this will be what? First class DCFL, because there is no confusion in push and pop. Okay. I hope I have made the point clear to all of you. Please note it down carefully. Let me put everything on one slide. Yeah. Please try to note it down carefully. Okay, so I'm jumping to next slide. See here, A power n, B power n, C power m, D power m. So again, very, very simple. We will push this A and from B, we will do pop. That means cutting. Now C power m, D power m. Nah. So that means what? C and D, there is no, you can say relationship between A, B, C. A and B, obviously we have relation. That means these two should be equal. And C and D, obviously these two should be equal. There is a relation, but there is no relation between n and m. Nah? That means n greater than m, n less than m, and so on. So there is no relation. So there is no problem at all. Okay, so we will do push, we will do pop. And whenever C will come, we should read the Z0 from the stack. Okay, now because we have read Z0 from the stack, so we will say that A and B are equal. Now we will start pushing the C. And we will push all the C, and then whenever D will come, we will do pop. Okay, so I hope I have made the point clear. So let me show you. If you are not able to follow, let me show you one example. Double A, double B, triple C, triple D. So what will you do? Initially we have Z0. We will push the A into the stack. Okay, now whenever B come, we will do cutting, and whenever C will come, we will start pushing. But when C comes, there should be guarantee that Z0 should be read from the stack. Because if Z0 is not read from the stack, that means what? A's are remaining. A's are remaining. That means what? Number of A's are already greater than number of B's. So why are you going to check C and D are equal or not? So you will directly say that the string is not present. So PDA should halt in that configuration. Okay, so we are going to apply only one move. That means that should be what? Delta. Say, let us suppose we are at state Q2 and we read from the tape C, we should read Z0 from the stack. Okay, we will not read A or B from the stack. I hope I have made the point clear. So C will come, we will do push, and whenever D will come, we will do popping. That's it. Okay, so I hope I have made the point clear. Next question, again very, very simple. So what can be done here? A, you will do push. B and C should be equal now. So B should be push, and from C we will do popping. So that means what? B and C are now cut down. Now you should have A's into the stack, and whenever D will come, we will do popping. So A will cut D, D will cut A's, and C will cut the B's. Okay, so let me give you one example if you are not able to follow. Okay, so see here, we will have say 2 A's and 2 B's. We have say 3 B's and 3 C. So what will you do? You will push all the A's. Initially we have Z0 into the stack in the stack now. Okay, we have Z0 in the stack. We will push both the A's into the stack. Now whenever B will come, again we will push all these B's also. Whenever C will come, we will do cutting. Okay, B's and C should be cut, and whenever D comes, then you should read A from the stack. Okay, there is no provision of reading B from the stack. If you are reading B from the stack, that means what? B and C are not equal. Okay, so PDA will halt in that configuration. So we have not given this move. Okay, so whenever D will come, then you should guarantee that only A should be read. So we will do cutting. Okay, D and A. That's it. So this is what? This is first class. We have constructed DPDA. There is no confusion in push and pop. So that means what? Both will be DCFL. What about this scenario? This is very, very important. This is very, very important. Please note it down carefully. Make star on it. It has come in many competitive exams, including GATE as well as NET. So what do you think? What should be done here? Okay. So you will say, okay, sir, no problem. Since A power n and C power n, so A and C should be equal. B and D should be equal. So logic is what? So you should push the A. Okay. And B, you should push the B. Now when C comes, then B will be read from the stack. Now you cannot read A from the stack. Okay. So whenever C will come, you have to cut down A's because A and C should be equal, but you have no access to A. You can read only B from the stack because B's are on the top. Okay, A's are not on the top, B's are on the top. I think you are able to imagine it. If you are not able to imagine, then no problem. I will take some example, but let me give you some intuitive idea that B's are pushed. So whenever C will come, then we have to read B. We are not able to access A. That means what? We are not even able to construct NDPDA for it. Okay, there is see, non-determinism means what? There is confusion in push and pop. So there is no confusion at all. I am saying whenever C will come, then how will you be able to access A's? You won't be able to access A. You can access only B's because B's are on the top. So that means what? We are not able to construct PDA or even you can say NDPDA for it. Hence, this language will be CSL. This won't be CFL. Please note it down carefully. Okay. So now if you are not able, still you are not able to follow, let me give you some idea. We have double A, we have 3 B's, we have double C, and we have 3 D's. Okay. So this is an example of A power n, B power m, C power n, D power n. B and D are equal, A and C are equal. Now see here carefully in the Z0, you have read A. So you will push all the A's onto the stack. You will push all the B's onto the stack. Whenever C will come, see here carefully, whenever C will come, how you will access this A? You have to access these B's. And if you want to pop all these B's, then how will you get the idea that B and D are equal? Okay. So there is no provision. I hope you have got the idea. If you are still not able to follow, please try to think it again and again and try to rewind the video and watch it again. Okay, so I hope I have made the point clear. So let me put everything on one side so that you can note it down carefully. Please try to note it down. Okay, so let's jump to the next slide. See here, WW transpose, I have already told you this is DCFL. So no need to waste time again and again. Okay, so it will be DCFL. Is this DCFL? No, because I have already shown you. Okay. Now this will be CFL. Okay. This won't be DCFL, but it will be CFL because we have constructed NDPDA. Okay. Just few slides back, I have told you. What about this? Again, this is very, very important. This question came in many times in GATE, NET, and many competitive exams. What is this? See, example of WW can be AAB and AAB like this. This is example of WW, na? So you will say that, sir, we will apply non-determinism, no problem at all. But see here carefully, how will you apply non-determinism? See, initially we have Z0 in the stack. You have to push this W onto the stack. You will push A, and B in this sequence. When A will come, you have to do cutting now. But cutting, how will you do cutting? See here carefully. You should cut this A with this A, but you cannot access this A because this is a stack. You have to access this B, this A, and then you can access this. So I hope I have made the point clear. So this cannot be done by PDA because of stack property. Hence, this is CSL. but not CFL. Okay, please note it down carefully. So these two are very important example or standard example. You can say WW and A power N, B power M, C power N, D power M. These two equal, these two equal. This and this. These two are standard examples. These are CSL, but not CFL. Okay. Okay. So let me ask you ask one twisted question. WW transpose, is this CSL? Of course, this is CSL because it is CFL, and every CFL is CSL. If you are not able to follow, please watch my Chomsky hierarchy videos. You will get the idea. Okay, I think lecture 3 or 4. Please, I do not remember the lecture number, but you have to see Chomsky hierarchy video. Okay, so this is CF. Can I say this is CSL? Of course, because this is CFL, and every CFL is CSL. Similarly, here, can we say that it is CSL? Of course, because it is DCFL, and every DCFL is CFL. Okay, and every CFL is CSL. Okay, so is this language CFL? If this question came, this is also confusing. Yes, of course, this is CFL. In fact, it is DCFL. Since it is DCFL, so it is CFL also. And this is CSL also. Please note it down carefully. Okay, please be careful. So this kind of twisted question come in many competitive exams. Okay, so I hope I have put everything on one slide. Please note it down carefully. Okay, yeah, so I'm jumping to next slide now. Closure properties of DCFLs. Okay, so now we are doing closure properties, transpose. I hope I have already told you about closure properties of regular languages, closure property of CFL, and so on. You can watch my video number. I do not remember. I hope 9 or 10 video. Okay, in chapter 1 itself, I have told you about closure properties. Please watch that video. You will get crystal clarity about what closure properties are and so on. So I'm not going to scratch the basics here. So I'm just showing you the, you can say questions, okay, or just showing you the operations. Okay, so first operation is transpose. So in transpose operation, DCFLs are closed or not. So I will directly say, you will think that L is A power N, B power N. So L transpose will be, sir, obviously you will say B power N, A power N, such that N is greater than or equal to 0. So obviously this is DCFL and this is also DCFL. So only thing is, so here A's are pushed and from B we are doing popping. From here B's will be pushed and from A we will do popping. So that means what? In DCFLs are closed under transpose. Can I say this thing? No, because I have just shown you one example. If you want to show that in transpose operation DCFLs are closed, then you have to show it for each and every DCFL, which is not at all possible. Okay, and if you want to show that DCFLs are not closed under transpose operation, then you just have to give me one counter example. So let me say this thing. Okay, so L is this. L is A power N, B power N, A plus B whole star. L transpose will be what? L transpose will be A plus B whole star, B power N, A power N, N is greater than or equal to 0. Now see here, is this DCFL? 100% this will be DCFL. A will be pushed, from B we will do popping, and after everything is over, then we can have any number of A's and any number of B's. So all these A's and B's will be ignored. For example, let me give you one example here. Okay, so double A, double B, and then we are saying that A, B, B. So this is from A plus B whole star, and this is from A power N, B power N. So this is very, very easy task. Z0 initially we will have Z0 in the stack. So I will push this A, I will push this A, and from B we will do cutting. And whenever Z0 is read from the stack, okay, then we will say this thing. Okay, Z0 means Z0 is read from the stack means what? A's and B's are equal. Now A's and B's are equal, then we will ignore all these symbols. Ignoring means what? A, B. You will read all these things and you will push nothing onto the stack. Or if you want to push, then you can push also, because we are doing it by final state. We are not concerned about null score here. Okay, so by final state, there is nothing to do with the stack. So it's your own choice. You push all these symbols or you push nothing onto the stack. You just ignore them. So finally, this is DCFL. There is no confusion in push and pop. Now see the L transpose. Now it will create confusion. Okay, how it will create confusion? Let me show you here. Okay, so let me take a string. Okay, so double A, double B, double A. Okay, and here double A, double B. So this is for L, na? A parent, B parent, and this is your string. See, this example is not that much perfect. That's why I am not taking this example. I'm taking this example. Okay, so just ignore this example. I have just shown you that this example was given just to show that L is DCFL. That's it. Now, for to proving that transpose is not DCFL, I am taking another example of L. Okay, or you can say another string from this language L. So A parent, B parent, that means N here 2, double A, double B. Now here we have A plus B, from A plus B whole star, we have this string. Now see here carefully. Okay, so there is no confusion. A's will be pushed, and from B we will do popping, and then we will ignore all these symbols. Okay, we will ignore all these symbols. A will be pushed, B will do, we will do popping. Now just reverse it. Just reverse this string. Double A, double B, double A, double B, double A. Now what will you do? Okay, now what will you do? So this is, so how will you say that A plus B whole star is string from A plus B whole star is over, and then we will do we will push these B's and we will pop A's from the stack. How will you show this thing? There is a confusion. Please think about it. You will get more clarity. The more you think, the more you will get clarity. Okay, so it will create a very big problem, or you can say very big confusion in our minds. Okay, so A plus B whole star, this is your A plus B whole star part. Okay, and then we will have B power n, A power n. Okay, so how will you show this thing? Okay, you won't be able to show it here, so hence it won't be DCFL. That means what? DCFLs are not closed under transpose operation. Okay. I have shown you a counter example that we have L DCFL, but transpose is not DCFL. Hence, this is you can say this is an indirect proof that in transpose operation DCFLs are not closed. Okay, I hope I have made the point clear. Let me put everything on one slide so that you can note it down carefully. Please note it down carefully. Okay, yeah, so if you are still not able to follow, just think about it. Just think about it. How will you show that? How will you say that A plus B whole star is over and B power and A power n has been started? You cannot say this thing. Okay, yeah, so let's move to the next slide. Union operation. Union, see here, this is a very simple counter example. You may think that in union DCFLs are closed, but I'm saying that in union also DCFLs are not closed. So how will you prove it? This is again very simple example. L1, A power and B power n, this is first class DCFL. A power and B power 2, again this is first class DCFL. Okay, why? Just push pop. I have already told you in the previous slides, just few slides back. Here also push 1A and make 2A's. Okay, so read 1A from the tape and make 2A's and push them onto the stack and so on. Okay, and whenever B will come, you will do popping and so on. This is also DCFL. This is also DCFL. Union. What about my union? You will get confusion. I have already told you A power and B power and union A power and B power 2 and it is not DCFL. So hence in union these union DCFLs are not closed. If you are still not able to follow, then let me show you the slide. Then you will get the idea. See here carefully. I have already told you. Okay, I have already told you that this is not DCFL. Okay, but this is DCFL. This is also DCFL. These two are DCFL, but their union is not DCFL. That means what? In union operation, DCFLs are not closed. Okay. Yeah. Next, intersection. Again, I have given you standard example. A power and B power and C power and C. This same example was given in CSL also. CFL also, and I have told you that in CFL, your you can say in intersection CFLs are not closed, and I have shown you the same example in intersection of CFL also. Okay, so if you are not able to remember it, please watch my video on closure property. You will get the idea. Okay, so now let me do it do intersection here, and I'm not showing you how exactly intersection is done and so on. If you are able to remember, then it's okay. But otherwise, it's homework for you. Try to remember it, or if you are not able to remember, watch my previous videos of closure property. I do not remember the lecture number. I think it should be 9 or 10. Okay, please do it yourself. Okay, so please search the video and you will get the idea. So this will be what I have already told you. This is CSL. Okay, so see here, this is perfect example of DCFL, because this is these two are DCFLs, so these two are CFL also. Okay, and intersection of these two DCFLs is giving us CSL. Hence, CSL which is not CFL. CSL but not CFL. And since it is not CFL, so it's obviously not DCFL also. Okay. So hence, this is a simple proof that in intersection DCFLs are not closed. Okay. So let me tell you one thing again. Why this is DCFL? Ignore the A, push B, and pop C. Okay. So you will do cutting. You will push the B's and you will do cutting with A's. And you can ignore the A, or if you want to push, then you can push also. There is no problem at all. Similarly here, push the A, and from B you will do cutting, and after cutting you will ignore the C. Okay, because cutting means what? A and B should be equal. Now, I hope I have made the point clear. Please see, this is wastage of time. I am repeating again and again. It won't help you much. Okay, please try to visualize yourself. Okay, so in intersection, DCFLs are also not closed. DCFLs are not closed in intersection. DCFLs are not closed under union. DCFLs are not closed under transpose. Nothing. Okay, so it is not closed. So concatenation, again, very beautiful example. L1 is A plus B whole star. You will say, sir, why you are taking a regular language? No problem, I can take regular also, because every regular is DCFL. Okay, so see, from Chomsky hierarchy point of view, this is your regular, and this will be your DCFL, and then you will have CFL, and then you will have CSL, and so on. Okay, so there are some DCFLs which are not regular. Example is very simple. You see here also, see, I have already written, this is not regular because there is comparison between A and B. This is not regular, but this is DCFL. So every regular is DCFL, but every DCFL is not regular. Why you can say every regular is DCFL? Because we are see, language is regular. When can we say language is regular? If we are able to construct FA for it. And if you are able to construct FA, then obviously you will be able to construct DPD also. There is no problem at all. Okay, so just ignore the stack. That's it. Okay, so DPDA means what? See, we have a stack now, so just ignore that stack. So it will behave just like a DFA only. Okay, so I hope roughly I have given you idea. Of course, I'm not going into details because this is a basic course. This is a fundamental course on TOC. That's why I'm not going in more details. Okay, so that's it. So let me finish it off here also. So I'm not going into more details. Okay, so I will give you more detail in your advanced course. Okay, so I have just given you idea that DPDA can behave like a DFA. How? You just ignore the stack. Okay, so it can behave, or ignore stack means what? You will not push anything onto the stack. Just ignore that stack. So that means what? It will behave like a DFA type. Roughly, it will behave like a DFA. Okay, so that's it. So so this is regular, and since this is regular, this is also DCFL. Now L2 is DCFL also. L2 is DCFL also. Now do concatenation of these two. I have already told you concatenation will be this, and this is not DCFL. I have already told you. See the previous slide. See here, this was not DCFL. Now because B power and A power n, na, so A power and B power n, obviously this won't be DCFL. This is obvious thing, na. A plus B whole star B power and A power n, A plus B whole star B power and A power n. This was not DCFL. So obviously, if A is here, B is here, so obviously it won't affect anything. So it won't be DCFL. Okay, so of course, in concatenation also DCFLs are not closed. So next, let's jump to next example. Next operation, complement. See, in complement operation, DCFLs are closed because roughly I have told you DPDA will just behave like DFA. Okay, DPDA without stack. It will be similar to, okay, not exactly same. Of course, it won't be same because in DPDA that configuration is allowed, but here that configuration is not allowed. Huh? In DFA that configuration is not allowed, but roughly they will be same. So they will be similar. And in DFA I have already told you, make final as non-final, non-final as final. You will get what? You will get the complement of the language. Similarly in DPDA also, roughly I can say that. Of course, you won't do. Please do not do that final as non-final, non-final as final. You will get complement of the language. But I'm just trying to visualize. I'm just trying to show you that complement operation DCFL will be closed, and rough idea will be that DPDA will behave just like DFA. That's it. So I will not say more, or I will not go into deep things. Just try to remember in complement operation, DCFLs are closed. But CFLs were not closed in complement operation. Okay, I hope you remember. If you are not able to remember, please watch my closure properties lectures. CFLs were not closed, but these CFLs are closed under complement operation. Okay, and the reason being DPDA is just like your DFA. That's one. Okay, let's move to next slide. Set difference. See, set difference is a derived operation. A minus B is nothing but A intersection B complement. So all those languages which will be closed in intersection and complement, that will be closed in set difference operation. In intersection, DCFLs are not closed, but in complement they are closed. So it hardly matters. I have said you that in both these operation, language should be closed. If both these operations set of languages is closed, then we will say that in set difference the languages will be closed. Like regular is closed in intersection as well as complement, so it will be closed under set difference operation. But DCFL won't be closed under set difference because it is not closed under intersection operation. So finally, set difference, it won't be closed. I hope I have made the point clear. Yeah. So union with regular, you have to remember it. All types of languages are closed under union with regular and intersection with regular. So I am not going into proof and all. So DCFL is closed. Since all languages are closed, so DCFL is also closed. And in intersection with regular, since all languages are closed, so DCFL are also closed. That's it. So thank you so much. This is all about your lecture 16. And in this lecture, we have completed the third chapter of your TOC, that means PDA and CFL. From the next lecture, that is from lecture 17, I am going to start your fourth, and that is the last chapter of your TOC, that is Turing machines and decidability. Okay, thank you so much. Bye bye.